Awesome. All right, hi, I'm Joe Arnold. I'm the CEO of SwiftStack, and what we do in a nutshell is there's a project in OpenStack called Swift, and it's an object storage platform. Thank you, Robert, for setting the stage on a lot of the concepts, particularly around key value drives, around some of the needs of the applications. And what I'm going to do in this, probably 10 minutes. So we've been working with Seagate as well over the past several months, and in OpenStack, Swift, we've developed an interface into those key value drives. And so tonight, we were part of that announcement a couple days ago, and tonight we're releasing that code in open source. So check tomorrow, because we gave them the engineers the deadline of tonight, so it could be midnight tonight, but that should be live on GitHub. So you can actually see and play with an open source project that is already out there. Here's how to interface with these devices. It really is, I think, quite revolutionary, no pun intended on that, change, because now instead of talking to a file, taking an object, because we're talking about object storage interface, instead of taking that object in and then translating that down into a file system where we have all POSIX compliant. Now we're writing, it's turtles all the way down. We take an object in and we put the object right onto that drive. It's a pretty neat thing. I'm really excited about that. But today I'm going to be focusing on the applications that we're seeing and how these interfaces are being used. And Robert framed this up exactly right. We're seeing applications that are mobile-based, that are browser-based, and we're going from an era from, instead of having a server closet somewhere where you're running Exchange Server or SharePoint, sorry to pick on Microsoft, Azure is a great product, that data is being moved into the cloud to applications like Box or Jive or Google Drive or even applications in general, like you look at Salesforce.com or Workday. Those are the types of applications that are great for a cloud storage from the perspective of the user, because they're using multiple devices, putting data into what we think of as the cloud, and then opening up another device and pulling that data down. And oftentimes they don't even think of it as data, they think of it as the application that they're using, and there's just data happen to be associated with that. Not as many PCs and laptops are being sold, more tablet devices. So we really are seeing that trend, and I think that's coming our way. So Object is a really good interface for these people building these applications, largely because it's an HTTP-based interface. So if I have my mobile device and I'm pulling data down, I'm pulling it down over HTTP. I'm not doing iSCSI out to some server somewhere to pull the data down. I'm actually pulling it down via HTTP. So it's a pretty good way to transport data in and around these applications that are consuming it. And then with data centers being further and further apart, it's actually a pretty good transport layer, because we know it scales. And again, Robert was talking about the drives down at the drive level. We're talking IP to those actual devices. So that means they can be anywhere. We route to them. And we know routing works pretty well, given that we're all using the internet every day. So the type of data is things like images, documents, media, log files, backups. Those are the types of things that are being stored in an object interface, not a database, not a running virtual machine, because we can't do POSIX compliance. We can't lock a file system. We can't say, hey, hold this record, nobody else touch it, and then release that. We can't do that. Only objects can be stored in an object storage system. So you take an example like Wikipedia. They use object storage to store all their images. And whenever you go fetch one of those things, ultimately at the end of the day, it's coming out of an object storage system being served up. Some caching in between, of course. So you have a cloud storage platform that people are looking to use, and one option is to use the public cloud. And the interesting thing here is that we've actually, there's a generation of developers, better for worse, who are getting trained up on how Amazon does things. And back in the day, I was part of building some of those early platform services on Amazon, and you can't even get a file system from them. You have to either go block or you do object. Those are your choices, so S3 and EBS. So then when it comes time for building your own private object storage system in your own data center, if you're not using a cloud-based system, and there's other reasons to do that, largely we see cost and performance are the main reasons that people do that, then choosing an open platform that developers already know how to use, it's an open ecosystem, makes a lot of sense. So that's what we have there. So use cases. One customer we have is an online gaming, and they have a lot of games, and they were in the public cloud, but then there was cost associated with that didn't really make a lot of sense for them, so they went in-house. First thing they did was they brought in their compute resources in-house, and the second thing they did was bring the object storage component in-house. And there they had, petabytes upon petabytes of backups that now makes it easier for them to have them in-house. Some of the other things that they do is distribute games out to like thousands of virtual machine instances all at the same time. I was actually talking about this earlier, where we do things like have 10 copies of things so you can boot up, you can distribute content out really quickly to lots of endpoints all at the same time. With them, it's a matter of concurrency. Object storage, because it doesn't have the concept of locking, is able to fan out across lots of systems simultaneously. And in that way, you can handle a tremendous amount of concurrency. So that's the strategy that is needed there. Broadcasting, really this is, instead of tape, let's figure out how to put this data into objects, and then we can do something with it. If we need to retranscode this, this is actually Pac-12, the sports guys, so if you're watching March Madness, they store it on an object storage system so they can do something with it. Then we put a gateway in between the object storage system and the workstations so they can continue. It's a Windows shop, and they can continue to do that. Service provider, it's a great use case because you can have multi-tenancy. You can have a storage system where each object is distributed throughout the cluster for a particular user. You don't allocate a volume, and then that volume exists in a certain location. You actually, everything gets broken up and distributed across the entire set of infrastructure. So you put lots of users in it, keep track of them, bill them separately, things like that. Another use case is like what Disney is doing around building game platforms and doing some rendering. And so they have a user-generated content game, which puts data up. Again, it's a need for, if you're seeing a pattern here, it's around lots of concurrency. And then they do something pretty, a couple of unique things. Even though we're an OpenStack project, they use the Citrix Cloud platform to actually run the gaming platform. And they also do things around LDAP. So again, one of the benefits of having a multi-tenant storage system where you can distribute lots of users from all over the place is you can have a centralized authentication system for them. And you can move users in and out of there. Kind of the last one is Concur. And what they do is they distribute data across multiple data centers. And so we'll use more than 3 replicas to put things in 2 different coasts, and then from a DNS perspective, we'll route them to that user to a nearest location. And that user will upload content. So if you're familiar, who's used Concur? They have like, you take a picture of receipt, and there's travel documents, all that kind of stuff. And so the upload happens really quickly because you're talking to a local storage pool, and then asynchronously that data gets replicated to the other site. then if one of those sites fails, well, you just kick everyone over to that other location, and the users don't really notice the difference. So it's sort of a combination of how do we give the best experience to the user who's using these mobile applications, and at the same time, how do we provide high availability when there's catastrophic failures. So we're talking about with them in Hong Kong. So the birth of this particular object storage system started with Rackspace. They had a product called the Rackspace Cloud Files, and it was largely built to be a competitor to S3. Then OpenStack initiative came along, largely spearheaded by them, and that was their contribution to the project. And then as a company, we've been building deployment tools around OpenStack Swift for a couple of years now. And just to reiterate, the point of an object storage system, at least in our worldview, is to handle lots of users. So how do we build up a system that can handle a tremendous amount of simultaneous connection? How do you 5,000, 10,000 concurrent connections into the system? How do we deal with that? How do we drive infrastructure around that? And that's some of the problems that we're trying to solve. Again, final slide, web addressable. Trying to be easy to use so you can consume it. Developers know how to use this API to build applications. High durability, 3 replicas and more. We also have erasure coding schemes that are coming down the pipe. We're built for a lot of concurrency and multi-tenancy, so you can have lots of users on the same equipment. Of course, standard hardware. So we care more about what the components on the inside of the box. No RAID inside there. We're very similar architecture to the way Nixon and ZFS are put together. So that's what I have. So thank you very much.